write subtraction on there. Subtraction. Wow. Try this all again. Twice again. Maybe down here. Wait a minute. I think I know what you want. It needs to be recalibrated. Under subtraction, please. This is where we talk about that one word I gave you before. And the book actually throws it in there. It is looking at the subtraction algorithm. Which, if you remember, the subtraction or the word algorithm just means what is the way, the process that you do a subtraction problem. And that simply means this, and we'll do one because I'm pretty sure you're relatively, if you have, let's say, $500 minus $63. What do you think, if we're writing down the algorithm for subtraction, what do you think rule number one probably is? Number one. Sam says, yeah, you're going to write it up and down. And here's where being neat and orderly is going to come into your benefit. So you have 500. And remember, part of the algorithm is we line up the right-hand digits, right? The 3 should go under that 0 and the 6 should go there. We don't have to always. Now, here's where I see people, a lot of people go wrong here. And I would like you, I'm going to blow this up for you, not physically. Oops, sorry. I don't want this one. I want this one. Some of you do this differently, but this is what I would like to see. Can I subtract 3 from 0? No, I cannot, correct? So that means what has to happen in our algorithm? Yeah. Alright, but you can't borrow from this one because there's nothing there, which means you have to borrow from 5. Now, here's the algorithm that I need for you to do. Okay, and I don't know how you do it. People do this differently, and I see 5th graders get this kind of confused because they do it in a different order there. I'm sure you all know that you cross off the 5 and you make it a 4. Yep. Okay? Yeah. Now, you know that when you take 1 away from the hundreds, that's the same as 10 tens. Okay? I need you to write that there. I need you to put, you're crossing off that 0. I want to see a 10 there. Okay? Even though all of you know that you're going to have to borrow from that 10 and it ends up being a 9. I don't want you to skip that step. I don't want you just, because you know it's going to be a 9, I don't want you just crossing off the 0 and putting a 9 there. I want you to write the 10 first, then cross off the 10 and make it a 9, and then make this one the 10. Okay? And that one doesn't become a 9 because you're not borrowing anything to that other column, it's just 1. Then you can do the subtraction. 10 minus 3 is 7. And 6 from 9 is 3. And then don't forget, you still have this 4 that's hanging over the edge there. Okay? Which, not to confuse you 5th graders, but even though I make you show a lot of work on all your stuff, I am a very big fan that you should be able to do a problem like this. Not that I would have you do it. Let me shrink this down. Because you understand subtraction, you should be able to do a problem like this. I put the wrong column in the wrong place. 8, 7, 6, 3, 2, 1. You should be able to do that problem actually in your head without even thinking about it. All right, the answer to that is 123,679. The reason for that is, now think about it. If you think about the process that you do in your algorithm, let me do it out for you. I put my 8, 7, 6 here, 3, 2, 1 there, right? When you do the whole algorithm there and you put all those numbers up there, what's it gonna end up being? Here, let's do it. This is a 0. This is a 10, it becomes a 9, right? This is a 10, it becomes a 9. This is a 10, it becomes a 9. This is a 10, it becomes a 9, right? This is a 10, it becomes a 9, and that ends up being a 10. When you do that subtraction there, you just have to think about what makes this a 9, 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 and the last one a 10. Because that's what it ends up being when you have a 1 with all those zeros. Everything turns to a 9 except the last one, which is a 10. So 8 plus 1 is 9. A 1. A 2 makes that a 9. A 3 makes that a 9. A 6 makes that a 9. A 7 makes that a 9. And what makes us a 10? A 9. That's what you get if you subtract them. So you don't have, and I don't want you to do that, but you should eventually be able to think about it. Let me do another one, make it, I probably should have done the easiest one first. How about 1,000 minus 527? The answer to that is, what makes this a 9? A 4, right? When you add it to it, 4, what makes this a 9? And what makes that a 10? Your answer is 473. Because, let me show you, when you add those together, guess what happens? Boom, 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 boom. Okay. Because of the algorithm that we use when you're changing things to 9 all the way down the line, as long as it's something that ends with a bunch of zeros, that works. You can't do that. If it was this, that all falls apart. You can't do that one. Because you got 8s and other things in there. But if you're like, you know, if you're doing a big round number and you do the subtraction, again, it doesn't matter if you got that, because we're not going to do that, but I just thought I'd throw that out there, because sometimes it's fun to look at some of that fun stuff there. Let's do another subtraction problem. How about 800 minus 406? 800 minus 406. So in our little algorithm, we do this subtracting. I'll give you a chance to do that, because I'm sure you've done this before, and I don't want to. Do that problem for me, and then when you're finished, circle your answer. I'm going to take a look. I'll walk around and see if you get some sort of a... Except you want to write it up and down. We're not doing these in our head. I just threw that in there because I was just so excited about that. Oh, you know what rock and soccer came from?
What? The rock and soccer. The old time game.
Mr. Allen used in high school. That's the originality of rock and soccer. I played it. Mr. Eddie Burke was sick. Like, boy, Mr. Rogers, Let's see if we ended up with the correct sort of deal here. And again, I very much need to see this. You can't borrow from the 0, so the 8's the first one you borrow from. I want to see this 10 up here. I don't want you skipping that step and just writing a 9, even though 9, it ends up a 9. And this one ends up being a 10. 6 from 10 is 4, which I believe most of you got. 0 from 9 is 9. 4 from 7 is 3. I don't think there's anything more different than that.